Hey there, STEM Chemistry. This is Ms. Ruark. This is podcast 5.6, where we're going to learn about net ionic equations. It's good stuff. All right, so types of chemical equations. We know that we can classify chemical equations as synthesis, single replacement, decomposition, double replacement, combustion, acid-base, and even redox. Well, we can take the chemical equations and we can say there are three types of them, right? So three types, meaning that we can look at them in terms of ions. So when we're talking about ions, there are three types of chemical equations. There are molecular equations, and the molecular equations are the ones that you are familiar with so far, such as this one here, where we have cadmium 2 nitrate plus sodium sulfide, and that gives us cadmium 2 sulfide plus sodium nitrate. Right? Well, we can also have what we call a complete ionic equation, and that means that anything that can be in ion form will be in ion form, but it also includes everything that's involved. Sorry about that. And the other type you can have is a net ionic. Oh, my pen doesn't want to be working. Okay, is a net ionic equation where it just shows those things that are directly involved in the reaction. All right, so a complete ionic equation. A complete ionic equation is anything that is going to be aqueous is broken up into ion form, because when you take a substance, okay, here's our water, our beaker full of water, and we have this cadmium 2 nitrate. If it's an aqueous substance, we're going to take cadmium 2 nitrate as a solid, there's my solid, and we dump it into the water. Well, guess what happens? When you take an aqueous substance and you dump it into water, it dissociates. Okay? It dissociates into the ions that make it up. So we have cadmium 2 ions and nitrate ions floating around in solution. Okay, so that's what it means when it's aqueous. It means that it's in solution and those ions have dissociated. They have broken apart. Okay, so anything that has an AQ after it, when you write it, you would have to break apart all of your aqueous substances. So it says we can write this as a complete ionic equation. All compounds that are AQ or aqueous are written as ions. So if it has an AQ after it, we break it apart into the ions that make it up. So we have cadmium with a positive 2, and we have nitrate with a -1. And guess what? Those are aqueous, so we write AQ after it. Now you don't have to, but I do just to keep track of it. Okay, and then we also have sodium sulfide, AQ. So we've got Na, and we've got sulfur with a -2 charge. Then on the other side of the arrow, we have cadmium sulfide, and this is a solid, and it does not break apart, so we would keep it as CDS with a solid after it. And then here we would have two sodiums, AQ, and nitrate, AQ. Now, notice I haven't written any of my coefficients in. You do need to make sure that this is balanced all the way. Okay, so when you do this, you'll have to go through and make sure that you include your coefficients so it's all balanced. So here we have 1 cadmium, we would have 2 nitrates. Why? Because there's 2 nitrates. We'd have 2 sodiums. Why? Because it's right here. 1 sulfur. Cadmium sulfide's fine. 2 sodiums and 2 nitrates. It does need to stay balanced. So when you write a complete ionic equation, you take your molecular equation, and anything with AQ after it, you break apart into ions. If it has S, L, or G after it, you keep it as the product. It's pretty easy, right? Yes. Time consuming? Yes. All right, so the net ionic equation. Here is your complete ionic equation, right? And to get the net ionic equation, we cancel out all terms that appear on both sides of the equation. Okay, so cadmium ion is here, and we look on the other side, is cadmium ion here? No, cadmium is part of a formula. It's part of a compound, but it's not an ion, so we can't cross it out. We have 2 nitrates here. We have 2 nitrates here. That's an ion. That's an ion. We can cancel those. We have 2 sodiums and 2 sodiums. We can cancel those. we have a sulfide, and then sulfur is part of something over here, so we can't cancel them. So after you cancel out like terms, then you would rewrite it. And you rewrite your net ionic equation like this, where you have your ions that are directly involved in the reaction and the product that they make up. Should be easy. All right. Equation must be balanced, so you need to make sure that they have a balance of materials. Both sides of the equation have the same number of each type of atom, and there has to be an electrical balance. So make sure that both sides of the reaction have the same net charge. You don't want to have a positive charge on one side and whatever on the other side. Okay, so here's a practice. When NaOH and MgCl2 are mixed, blank and blank are produced. Write the balanced molecular, complete ionic, and net ionic equations. So we've got NaOH, which is aqueous, reacts with MgCl2, which is also aqueous. Okay, when that forms, those two come together, we end up with a salt, NaCl, which we said is aqueous, and you know that from your solubility rules. And the other one that's going to be formed is MgOH. Well, Mg has positive 2 charge. OH has a -1 charge. Cross those down, MgOH2, and you need to look at your solubility rules. So hydroxides, I believe that's rule number 5, but I'm not sure. Hydroxides, most of them are insoluble, and this one is, so it's a solid. All right, so first, before we do anything, we got to balance this molecular equation. We have 1 sodium, 1 hydroxide, 2 hydroxides. So we put that here. That gives us 2 sodiums. Oh, we got to fix that. Now we have 2 sodiums, 2 hydroxides on each side, 1 magnesium, 2 chlorines, 2 chlorines. So it's balanced. All right, this is your molecular. For your complete ionic, anything that has AQ after it, we break apart. This has AQ after it, so we have to break it apart. So there would be 2 sodiums with a positive charge and 2 hydroxide ions with a negative charge. This has AQ after it, so we're going to have to break it up. We have 1 magnesium with a positive 2 and 2 chlorines with a negative 1. Our arrow, this has AQ after it, so we break it up. 2 NAs with a positive charge, 2 Cls with a negative charge. And this has an S after it, so it does not get broken up, it stays. And don't forget to write S after it. Okay, that way you can tell them, hey, that's why it's staying. All right. Now for our net ionic equation. Anything that shows up on both sides, you cancel out. Well, guess what? Another way to do this, don't tell anybody I told you, is super secret, right? Find out what your product is. What is the solid, the liquid, or the gas? What's this? All right, so we know that our product is that. Well, what makes that up? Well, magnesium and 2 hydroxides. Oh, look how easy that was. I know, it's so easy, right? All right, so you've got 2 ways you can do this now. Either one is fine, whichever one you want to do. All right, it says identify the spectator ions in the following complete ionic equations and write the net ionic equation. Remember, the spectator ion is whatever shows up on both sides. All right, so copper is on both sides and chlorine is on both sides. So our net ionic equation has these compounds, and it doesn't matter what order you write them in, as long as they're both on the reactant side. You put both ions on the reactant side, and then on the product side you have your salt. Easy, right? All right, we have lithium and nitrate. So we have lithium and nitrate. Both of those are your spectator ions. Cross them out on both sides. What do you have left? You have Fe with a positive 3 charge. And you have 3 hydroxides with a negative charge. And you produce FeOH3 solid. It should be good, and it should be balanced. All right, here's another one. Write the complete ionic equation, cancel out spectator ions, and write the net ionic equation. Break that apart. So we have 2. Ooh, no, we don't have just 2. We have how many? We have 6. 6 sodium ions plus 2 phosphate ions plus 3 calcium ions plus 6 chloride ions. Oops. And then that produces calcium phosphate. And then we have 6 sodiums and 6 chlorines. All right, so what is my net ionic equation? Take my solid Ca3PO42, right? And that's made up of 3 calciums and 2 phosphates. And see, it's the same as this. Yay! And it's balanced. Yay! All right, down here we've got 4 sodiums. We've got 2 sulfurs. We have 2 silvers. Remember, the silver has a positive 1 charge. And we have 2 acetates. Acetate has a negative 1 charge. All right, this one. Oh, look, Miss Ruark, so mean. She didn't give you what they were. So you have to look at your solubility rules. All right, solubility rule number 1 says if it is a group 1 metal, that's a group 1 metal, it will be AQ. Right? And then there's another one, I can't remember if it's 4 or 5, says sulfides. This one's going to be a solid, isn't it? Yup. All right, so we would have 2 sodiums and 2 acetates and Ag2S solid. And it's balanced. Okay, what's my net ionic equation? Well, we know that we're making Ag2S. What makes Ag2S? Well, 2 silvers with a positive charge and 1 sulfur with a negative 2 charge. It's okay to work backwards. All right, use the solubility rules to predict products and write the net ionic equation for the following reaction. So this is a single replacement reaction. Do I need solubility rules? No. Do I need to have my activity series? Yes. All right, and according to my activity series, aluminum is higher on the chart than hydrogen, so it comes in, knocks out hydrogen. We end up with aluminum and sulfate together. Hydrogen's crying in the corner. Aluminum has a positive 3 and sulfate has a negative 2. Don't forget to cross them down and put your parentheses. So Al2SO4 plus hydrogen, it's Brinkelhoff, so we have to put a 2. Is it balanced? Well, let's check. We have 2 aluminums, we need 2 aluminums, so we got to put a 2 there. We have 3 sulfates, we only have 1 here. Let me erase some of this because it's a hot mess. Yeah, we want to be able to see what we're doing. Okay, there we go. All right, so we have 2 aluminums, 3 sulfates. Let's put a 3 here. That gives us 3 sulfates, 6 hydrogens. Let's put a 3 there. There we go. All right, what's my net ionic equation? Well, that's not really fair, Ms. Ruark, because it's a single replacement reaction. Okay, well, aluminum sulfate. Is aluminum sulfate a solid? Well, it doesn't work anyways because it's soluble. So there's your equation. We can't do the net ionic equation. Sorry. Moving on. All right, we have HCl and BaOH. So this attaches itself here. This ends up here. We end up with H2O and BaCl2. H2O is a liquid. Barium chloride. What's that one going to be? All right, barium chloride is going to be aqueous. Okay, so when we write our net ionic equation, we're writing it for this. So we would have hydrogen plus hydroxide, and that gives us H2O. Okay, is it balanced? Well, let's look. It does not appear to be balanced. It looks like we have 2 hydroxides, so we need to put a 2 here, and then we need to put a 2 there. So we should have 2 and 2 gives us 2. So yeah, I guess it was balanced because it's a 1, 1, and 1, right? Okay, last one. Sodium. So we have NaCl. We know that's aqueous. Let's go ahead and put that in there. Okay, and then BaPO4 would be Ba3PO42. That one's going to be a solid, and I'm going to run out of time, so you would keep writing with that. Oh, yay, that's it. All right, guys. So I will see you in class, and we'll do more practice.